Hi, everyone. We're back with another very brief worksheet for Chapter 27, which is very brief. Chapter 27 is another biochem chapter for us, and it's on the topic of lipids. Now, lipids are, broadly speaking, a class of biomolecules that are fat soluble as opposed to being water soluble. And what you will find about such compounds is that they're overwhelmingly comprised of hydrocarbon. Yes, there may be an occasional polar functional group on the molecule, but the vast majority of the molecule is hydrocarbon, looks fat soluble. And so here we have several of the different types of lipids that we'll have gone over in class. And on the worksheet, I asked you to identify each one of them. Now, likely on the exam, you're not going to have to identify all of them. But as I said on the worksheet, more practice is always better than less practice. And so what you'll need to aim to do for the exam is to be able to distinguish and identify all of the different types of lipids that we go over in class by their structure, by what functional groups are present, what functional groups are absent, what type of rings are present, if any, and so forth. So let's start with this first one at the top left. And I'm hoping that you guys recognize that it falls into a class of compounds that includes several other subclasses of compounds, but all of them have this tetracyclic framework. I remember a biochem book that referred to this as the 3 rooms in a garage. So it's always 3 6-membered rings and a 5-membered ring fused exactly like this. And compounds that have this tetracyclic ring structure include cholesterol, include sex hormones, include bile salts, also called bile acids, include cortisone, and include a lot of other hormone-related molecules like that. So the first thing you always want to do when you're given a molecule that has this tetracyclic structure is look at this ring fusion, the one I've labeled in red over here, the one between the so-called A and B rings. So there's the A ring, there's the B ring, there's the C ring, and there's the D ring. That's what biochem textbooks will call them as well. That's where you want to look first. You want to look between the A ring and the B ring. And if that ring junction is cis, then you've got a bile salt, also called a bile acid. If that ring juncture is not cis, either by virtue of being trans, which actually I've never seen, or what you'll most likely find is that instead the ring junction has no cis or trans distinction due to either or both of those carbons being sp2 hybridized. In that case, it's cholesterol, it's a sex hormone, it's something other than a bile salt. If you look at this compound that we're given right over here, and you look at that ring junction between the A ring and the B ring, you can see that the methyl group and the hydrogen are cis to each other. They would be cis to each other if these were both wedge bonds or dotted bonds. In this case, they're both dotted bonds. Since those two groups are cis to each other, the hydrogen and the methyl group, we conclude that this is a bile acid or bile salt. I don't care what you call it. Both terms are correct. So again, when you're given one of these tetracyclic structures, look at the ring junction between the A ring and the B ring first. If that ring junction is cis, you've got a bile salt. If it's not cis, then you've got something else. Could be a sex hormone or cholesterol or some other such thing like that. Moving over to the next compound, this is a little trickier. It's not a fatty acid. It's not a bile salt. It's not cholesterol. It's not a sex hormone. It's not a prostaglandin. It's not a triglyceride. It's not a phosphatidate or a phospholipid. all we have is this ketone functional group on the molecule. But we'll have covered another class of lipids known as terpenes, where you can have a monoterpene, you can have a sesquiterpene, you can have a diterpene, and these will all differ in the number of carbons that they have. A monoterpene, sometimes just called a terpene for simplicity, will have 10 carbons. It is 2 5-carbon isoprene units. And don't forget what isoprene is. Isoprene is effectively 2-methyl-1,3-butadiene. So this is isoprene, and it's a useful compound to know the structure of. And in a monoterpene, there will be 2 of these 5-carbon isoprene units for a total of 10 carbons. And also these methyl groups that stick out are usually pretty easy to pick out. You can pick out both of them. So if there's 10 carbons, you've got, and it doesn't fit into any other category, then you've got a monoterpene, or you can also just say a terpene. If there's 15 carbons, you've got a sesquiterpene. Sesqui is a rarely used prefix meaning 1.5. So 1.5 times 10 is 15. So a sesquiterpene will have 15 carbons. And a diterpene will have 20 carbons. And there also are some triterpenes with 30 carbons. If we count the carbons in this compound, there are 10 of them. And not only that, we can pretty easily pick out these methyl group isoprene tails. There's one over here, and there's one over here. So this compound consists of 2 5-carbon isoprene units for a total of 10. I am fine with you calling this a terpene or a monoterpene. And you will know which to put on the exam based on the choices that you're offered. So what about this next compound? This next compound looks an awful lot like a fatty acid, except that it has this 5-membered ring fused in the middle of it. And that was a clear sign of the structure, as we introduced it, of a type of lipid known as, why am I blanking on it? I might have to come back to this, but this is one of the lipids that we'll have gone over. I did mention a fatty acid. That's going to be this molecule over here. Anyone watching this video is screaming it at me what these are called. I will look it up if I absolutely cannot remember. But this would be an example of a fatty acid. One thing you might not be used to seeing, but you'll need to get used to seeing, is this type of shorthand for a very long alkyl chain. It's basically CH3 followed by 18 CH2s. So if you didn't know that, please learn that, because it might be given to you in this form. So all told, we have a 20-carbon carboxylic acid. That's going to be a fatty acid. And I remembered the other thing, but we'll go back to it in just a moment. So what we have on the left, which I finally remembered the name of, looks like a fatty acid. See, it is a carboxylic acid group on the end with a whole bunch of carbons, but there's a 5-membered ring fused into the structure. We call compounds of this type prostaglandins. And they're pretty important. They're involved in the pain response and things like that, and other such processes in living systems. So just to the right of the fatty acid, we have the conjugate base of the fatty acid as a sodium salt. And so those are soaps. Soaps are alkali metal salts of fatty acids. And in general, it turns out that sodium salts of fatty acids are solid soaps, such as you find in bar soaps, while the potassium salts tend to be liquid soaps, like the stuff you pump out of those bottles. Finally, just below that, we have, again, a part of a long-term fatty acid in a functional group that you need to recognize. This is an ester. And so we have part of a long-chain fatty acid with 16 carbons, and the other part comes from an alcohol. That fits the definition of an ester, as we gave it last term, an organic one. So this would be a very long chain alcohol, right, with 30 carbons connected to an oxygen compared to a 16 carbon carboxylic acid portion. And so fatty acid or long chain alcohol esters of fatty acids are waxes, and this would be a wax as we defined it in class. And then finally, the last two, this species doesn't fit into any of the other categories. So what you do in that case, if you're given a compound that doesn't fit into any of the categories, count the carbons. And I think you'll find if you count them that there are 15 carbons. Not only that, it's pretty easy to pick out 3 methyl group tails from isoprene units. There's one, and there's one. So there's a total of 15 carbons. And again, you can see what I mean by calling compounds like this lipids. Yes, there is a polar alcohol functional group in this molecule, but overwhelmingly, its structure is described by hydrocarbon. There's 15 carbons and one OH group. So it's much likelier to be fat soluble than to be water soluble. And that's basically the definition of a lipid, right? A molecule that's fat soluble, a biomolecule that's fat soluble. So this guy has 15 carbons and composed of 3 5-carbon isoprene units. It's a monoterpene, has 10 carbons. This has 15 carbons. 15 is 1.5 times 10, so it's a 1.5 terpene. It's a sesquiterpene. And again, we'll have gone over that in class. You can check out the class notes for some more examples of that structure. And then finally, we come to this structure. This structure does not look fat soluble. We've got 3 polar alcohol functional groups, all of which can undergo hydrogen bonding, as well as a pyridine type nitrogen, which can also undergo hydrogen bonding and is also a polar group. In what is otherwise a very compact molecule, you've got 5, 6, 7, 8 carbons with all those polar groups. So this is a water-soluble compound. And the only type of water-soluble compound we'll have talked about in class is a water-soluble vitamin, which is what this is. This is actually a B vitamin. So the way you know you're looking at a vitamin is, again, if the structure doesn't fall into any of the other categories, and then you can distinguish whether it's a water-soluble vitamin or a fat-soluble vitamin by the structure. A water-soluble vitamin will have a large number of polar groups compared to the amount of hydrocarbon that's in the molecule, whereas a fat-soluble vitamin would consist largely of hydrocarbon. And I would encourage you to look up some structures of some vitamins. Look up the structure of vitamin C, which you probably know is a water-soluble vitamin. It's loaded with OH groups. Whereas if you look up the structure of something like vitamin A or vitamin K, I believe, these are fat-soluble vitamins. And you'll find they consist mostly of hydrocarbon. So these are not all of the lipids that we went over in class, and this is not an exhaustive description of everything you'll have to know about lipids on the exam, nor do I promise that there won't be other questions on lipids. But this is a goodly chunk of it. This is what we spent the bulk of the material in class time talking about, or will have spent, I should say, since as I speak, it's 2 days before I'll be giving the lecture. But take a look at the worksheet. The answers are there as well. And of course, you can find other questions of this type on the practice exam as well. So we'll leave it at that. I wish you all a pleasant weekend, and I'll see you all on Monday.